Welcome everybody. In this video, we will be looking at how you can stack or add together the individual images that you've taken with the LCO telescopes. You remember you've taken 3 images in each filter. And what we need to do is we need to add them together or average them, which is called stacking, to increase the signal to noise of the images. And then we're going to use these stacked images to actually upload into our HOYS database to do the photometry, i.e. the brightness measurement of the stars on them. So we're going to do this with what is called a Jupyter notebook, which in essence is some form of Python code. And on the website, there's a link to where this notebook can be opened at Google Colabs. And what we'll do is we'll just go straight to that website. And what you will see on the main part of the screen, that is in essence the entire notebook. There's a couple of descriptions and some comments in the code, and mostly you have basically the individual code lines organized in different blocks. What you need to do is basically you need to run these blocks one by one, and I'm going to talk you through those, what they're doing. You need to at some stage upload the images that you have obtained. So they should already be on your computer. So you need to download them from the LCO archive. If you haven't done that yet, please have a look back at the previous video, which explained how to do this. So to run a block, the simplest is you go to that little square bracket here. If you hover the mouse over that, you get a play button, which will execute the block. You can also press Shift and Enter on your keyboard if you so wish. So the first block, if you run this, it always gives you this kind of message that this wasn't written by Google. So you can run that notebook. It's perfectly safe. What that first block is doing, it's installing a software package which we are using for the image stacking. So that's the package called Montage from NASA, which is not part of the standard installation. That's why we have to actually install that before we can run the rest of the code. The second block simply imports all the other packages that we need, and you can see when the block is running, afterwards it tells you how long it took, and it also highlights with that green arrow, which you might have seen, which parts of the code have been done. So this just imports everything we're gonna need later on. The third block simply asks you for a username. So that should be some sort of identifier, which will be added to the file name of the stacked images, which we then download. So again, I'm just gonna use my initials, but please do that so that you when you download the images, yes, you can rename them, but that the images are identifiable to you or as yourself, because you'll see later on when you upload them to the HOYS database, you need to know which of the images are yours. So your name should appear in there. So whatever you put in there as name will appear in the file name. The block after that creates some directories, in particular the directory where you can upload the images into. And the block after this, in essence, tries to make a list of all the uploaded files in that directory. Now, at this stage, that list is empty, that it produces, because we have not uploaded our images. To upload the images, you go on the left, you go to this little folder symbol and click on that. The block that we have run, the one just before, that has created these three directories, and we need to upload the images into this directory, which says upload raw images here. To do this, you click on the three dots on the right, you select upload, and then a browser should open up, and I just need to go where I have placed my images. So you should have typically 9 individual images from one of your observing block. If you'd followed the instructions, the first 3 should be visual images, then the next 3 should be red images, and then the next 3 should be the infrared images. But make sure you know which of these images are from what filter. In this case, I've checked this. The first 3 are the images. So these are the uncompressed images that I have downloaded. You can also download the compressed images, these images that end with .fits.fz. They're much smaller. You can see the uncompressed ones here. They're about 240 megabyte each. In any case, what we suggest is you only upload all the images from the same filter. So you select the 3 that belong to the same filter, and this one, the visual, and then you press open. Again, there's some warning message which you can read and then simply ignore. And what then will happen is the image names, they will appear at the bottom, and the upload process is started. This will usually take a while, depending on how fast your internet connection is and how busy the servers are. This can take a few minutes, and what you see is, while we're watching this, for each of those images, there's a blue circle starting to form, and the image is fully uploaded if that blue circle is complete. In particular, if you, so as I said, please try to just upload 3 images at a time. If you want to try and upload all 9 of them, this can take quite a while. So what I'll do is I'll pause the recording for a moment until the images are uploaded, and then I'll come back. Okay, so the images are uploaded. So if you now have a look in the directory, they're all there, and we can hence progress with the notebook. So we need to rerun the block that makes the list of files for the directory. So now they have shown up in our list here of the ones that we have uploaded. The next block basically does some work in terms of cleaning out some directories, which is only really needed if you are running the script several times with different images. And so the block after that again tells you which filters the data is for, and for what object the data is for. So in this case, this is from the Pelican Nebula IC5070. So all the images are for that region, and all the images are also for the visual filter. As I told you, it's the first 3 in this block, so they should all be for the visual data. The next block simply introduces the actual function which will do the stacking in a couple of steps time. So we just need to run that so that the code knows what that function is and how to execute that. So the block after next simply creates a list of all the filters for which we have data. So since we only have uploaded the visual images, there's only one filter on the list. But if you upload all the 3 or the 9 images, so you have data and 3 filters, you have an option which of the filters you want to actually stack. So we select the visual because we only have that, and then we run the actual stacking procedure. Now, this procedure is using that function from above, and it's a kind of a separate software in the background that Python is just using. So what that software will do is will create some files and some directories. You've seen them show up on the left-hand side. What it will basically do is it will take the images, look at their coordinate system. It will align the images so that the same coordinates are in the same place. It then does some kind of background adjustments of one picture has a slightly higher background than the others. That is all corrected, and then ultimately it will average these images out. Now, you've seen the pictures are quite large, so 240 megabytes, and there's 3 of them. So this process will take a while, so a couple of minutes usually. So please be patient, just let it run. What the function will do is it will, over time, while it is stacking, print out some progress information, which you can see. That is usually only a small bit of text. But if something goes wrong, for example, if you accidentally have uploaded one image of a different region or something like that, then you'll get some warning messages that one of the pictures doesn't overlap with the other two, and so forth. So again, I will briefly stop the recording while this is running, and then we come back after the process has finished. Okay, so the stacking has finished, and you can see from the runtime here. In this case, it took 8 minutes. Sometimes it takes just about 6. That really depends on how busy the server is, where this website is running. You can see these are the normal outputs that the software will generate. So basically keeping you informed what it is doing all the time. So if there's no problems, this is basically what you should be getting. The image that it has created is in this directory here called final stacked image. So you see what it has done. It's basically called the image LCO, then the object name, the filter, and then the name that you have added to this. Remember, all the pupils from all the schools that take part do exactly this. They will some of them will have observed the same target and the same filter, and they will upload their images to the same account on the HOYS database. So that's why it is important that you add your name or some identifier that makes clear that this is your picture to the file name, because only then can you identify that. If you upload an image called IC57TV, then if you find there are 10 of them, you don't know which one is yours and which one you need to process. So the first thing you should do once this is finished is download that image onto your hard drive. So again, you do this by clicking on the 3 dots on the right, select download. That will open a a browser on your computer after a while, and then you just select the directory where you want to store the data, and then it will download. So sometimes it takes a little while because it needs to basically extract the image from the server it has generated it before it opens the download. So again, depending on your internet connection speed, this can be taking a while. So again, just be patient until this process has finished. And so you can see it basically just opens the same directory. I've done this before. You can see I've downloaded these pictures, but if you just press save, it will basically save the file into that folder. There's one more thing at the bottom. There's a last block that you can run. This just creates a display of the image that we have just created, so you can see how this looks. So it basically makes a JPEG version of this. The picture doesn't look like much. You can play a little bit with the settings here to kind of have a better look. Please experiment with this. We have a completely separate video that shows you how you can view these images and even make color pictures out of them. So I'm not gonna talk a lot about how this works on this, but please experiment with that. So what we've now done is we've stacked the 3 images in the visual filter. And now we, in principle, just need to repeat the process for the other filters. So the advice would be to either just delete these images because we don't need them anymore. So you right-click, click delete file, and so forth. And then you go and you upload the next 3. You go back to the very top where you're making that list of all the files, so you don't have to rerun the blocks above the one that makes the list. So this one is the first block that says raw images, upload raw images here. This is the one you need to rerun to get a new list of the new files that you've uploaded, so that the code knows what they're called and where they are, and then you can repeat the other steps in exactly the same way. The next one in the normal list would be the red images. You do that. Once it's finished, you download that file, and then you repeat the same process for the I-band images. I'm not going to do that for the video, so one image at the time. Once you have all of them, we can have a quick look what that process actually is doing. So I've taken here some of the red images. I've chosen red images because they have a lot of nebulosity from the hydrogen alpha filter. And on the left is one of these 3 individual red images that I have from that sequence. And on the right, this is the picture that I've created with the stacking. And you can see the picture on the right looks a little bit more smooth. So the signal to noise has increased, i.e. the noise in the picture is dropping if you add images together. And what it means is the nebulosity is much clearer, it's nicer and smoother. That's nothing that we're really interested in the project, but also the stars are much more clearer. So if you zoom in a little bit, you can really see that, for example, if you look at this star here, it shows up in the top right corner as well in a stack picture. It kind of looks reasonably clear. We might be able to do some brightness measurement on that. On the left image, which is one of the raw ones, it looks much more noisy, much more pixelated, and the scaling on both pictures is the same. You can very clearly see the picture on the left is quite a bit more noisy, and we've only added 3 images together. So if you add even more than 3 images, these stacked images become much better. You can see the fainter stars much more clear. You can kind of see that here. There's a bunch of faint stars which show up reasonably clearly, in particular those 2 where in the individual images they can be quite noisy, and you will definitely not be able to measure any brightness of these images in these individual frames, but you can do that for the stack data. So that is basically it. Again, if there are any problems with that procedure, if you encounter anything that doesn't work, something unusual, kind of make a post on a Facebook group. Again, if there's private data involved, that's obviously not a good choice. Email Dr. Fröblich with any questions, maybe via your teacher. that you have, or send us a tweet. We will look at those as well. In all cases, try to include some screenshots and some details, which will able to really help us to help you much quicker. So if you know what image data set you've used and what's actually going wrong, then we might be able to help you reasonably quickly. The next video will then look at how you take these images that you've stacked and downloaded onto your computer, how you then upload them into the HOYS database and process them so that the brightness of all the stars gets measured and added to our catalog of brightnesses of the stars. So that will be the next video. Thank you.